Hello everyone, welcome back to my SDL2 on Xcode series. In this tutorial project, we are going to build the classic snake game on Xcode using C and SDL2. This is episode 5. So last time we goes over a manager which we are going to use to manage resources. So let's go over what we have done last time. If we look at this manager header, we have defined a structure called wtManager, which is responsible to load all sorts of different kind of resources. It will provide three important functions. The load function to load the resources from a path, and then we have the unload function to free the resources. And also we have an error function in case we encounter some errors during the loading process. And that is the three most important functions during a resource management. And then within this manager, we also have a name for it. We have an array to store all the items and the capacity, meaning the size of the array. So, and also within our engine, we define four kinds of manager. The first one is the texture manager, which is responsible for loading images. And then we have, in this case, the load function basically is a function that wraps around the image load texture. The unload function is SDL destroy texture, while the error function is SDL get error. Now, the next one is the phone manager, which are responsible for loading phones. And the next two are the music manager and also the chunk manager. They are actually a manager that they are actually managers that wrap around the mixer extension library for XDL2. Now, since we have this manager in our engine, we should clean up the memory claimed by the manager when we exit our engine. So we have, let's go to the engine clear function. Within our engine clear function, when we try to clean up the memory, we should clear all our engine using this manager clear function. And that's how we manage the managers within our engine. Now in this episode, we're going to see how we're going to use these four managers to load all resources needed for the game. Now for that, we have done it in a file called resource.h and resource.c. Let's see what is it in there. The resource.h exposes only one function, resource load. This function will load all kinds of resources defined in these header files. You can see that here I have four enumeration corresponding to four kinds of different resources. The one that starts with T is actually for the texture. So for example, T underscore apple means that this is a texture for an apple. Basically, it's corresponding to let me see, snake, and then this apple PNG here. So that is what T underscore apple will represent. And then we have all other stuff. For example, the body bottom left, that is the body of a snake that we're going to use in our snake game. And then this part are all about the snake. And then we have some glasses for us to draw the background, and here there are some subparts of the glasses. These are the texture we're going to use so far. Maybe later we're going to introduce more, but that will be enough for now. And then for the font, we are going to have only one font, and this font is located here. Now 32 means that we are going to use this font in size 32. Maybe later we are going to need more font to display more information. But again, for now, we just stick to only one font. And then M, the prefix M means music. So these two are the resources for the musics, and they corresponding to two MP3 files in our audio's assets. And finally, C means chunk, and this is a sound effect for a snake eating a fruit, and it's corresponding to this OGG file. So these are the resources that we are going to use by now. And let's see how we are going to load all these resources in this function. Let's go to the implementation. Now in here we have a private structure called resource item type, and it represents the one resource. For example, it has the ID for that resource and the path to that resource, and maybe some extra argument to load the resource. And here the rectangle this rectangle is something that we are going to use to load texture. The reason why we need this one is the following. If you look at the images here, you can see that each image represents one part, and that's good, and that is easy to load up. However, there are some texture that will include a lot of subparts. For example, in here, there will be 4 textures within one row, and there will be 8 of them in total in this one image. So we need to have another argument that will represent a smaller subpart of this texture that we are going to take out. Now let's go back to the resource.c, and we will have a function that will count the number of items within one kind of resource. You can see that by convention or by decision, I choose -1 as our pivot values to indicate that we end here. The reason is that enumeration starts from 0. So here all the ID are positive. If I see some -1, that means we stop here, and that's how we know when to stop. And using this pivot position, pivot number -1, I can compute the number of items within one resources. For example, I will just go count one by one until I hit -1, and the number of ID I saw will be the total number of count in this resource group, and that's the idea, to count the item in one group. Now let's see how I lay out the resource items in one group. You can see that I have the t_apple, that is the ID, that corresponding to snake_apple.png, that corresponding to this image here. So that's how I associate the ID with the path using this structure here. For this one, we just need the path to load the texture, so that is enough. So that is the reason why we have only 2 items in this first entry. And then that would be the same for all the images within this snake folder. And next, we have a t classes for pointing to the glass.png. And remember that this glass.png has a texture within it. So in the following 8 items, we're going to have, for example, the first subtexture within this glass structure will point to, you can see that I use the extra part here to represent that the parent ID. That means this t-glass light 0 is actually part of the t-glass. So for that, I don't need the path because it is already loaded. And then I used a SDL rec to represent the area of our subtexture. And that is the reason why we need this. You can see now this is used to locate the subpart of our texture. Then the same for other subtexture. There will be 8 of them in total. That is how we define the correspondence between the texture ID and also the resources. Let's see how we load this up. We load this up using the function called resource load texture. First of all, we are going to see how many items we are going to load. And this is important because we need it to resize our texture manager. And that's how we do it here. If we fail to resize the text manager, then we will just return false, indicate that we cannot load all the texture successfully. Otherwise, we're going to load the texture one by reading the resource item here. And actually, it's not too hard to do so. First of all, we can check the path of the item. If we have a path, that means if something like this exists, that means this ID will corresponding to this image directly. So all we need to do in this case is to load it directly using the manage load function, and then put in the remember that this will take in a manager, the resource ID, the path to the item, and also some extra argument. In this case, there's no extra argument, so I use now, and that's how we load a texture if we have a path. Otherwise, we know that if there's no path here, then this is actually a smaller texture within a bigger one. So we will going to get the parent texture, the larger texture, using the manage get function. And remember that the extra one will corresponding to the parent texture ID, and that's how we get it. And then we will use a utility function to crop our parent texture by this given rectangle, and that will give us a new and smaller texture. If we cannot do this cropping, then we return false. Otherwise, we will just we'll use this set function to set the ID entry of the texture manager to be this child or this subtexture. Now let's go to this definition and see how we do this cropping. It is defined in the utility set, and it's not too bad. First of all, we check that whether or not our texture is null. If it is null, then we cannot crop it. And then we will use the renderer in this cropping process. Next, we're going to create a texture that will hold the smaller texture within this bigger one. So that's how we do it here. After we create this texture, all we need to do is to set the blend mode of this created texture to be blend. And then we set the render target of our renderer to this new created texture. And then we are going to execute a command render copy. That means we're going to actually draw our texture, not the whole texture, but this given area to our target texture here. After we successfully draw it, then we achieve the goal to crop that part of our texture, and then we return the crop texture. And that's how we get a smaller part of a bigger texture. Now let's come back to here, and that's actually finish the loading process for the texture. And then for others, we have a similar process to load all these kind of items. First of all, we set the ID corresponding to the path to the resource. In the font case, we need to have some sort of extra argument. In this case, we need to have the size or size that we would like to have. In this case, it is 32. We can easily change this one to other number if we like. Now next, for the music and the chunk item, they are actually the same as before. We have the ID and also the path to the resource. For these three groups of resources, we can load them using a same function, which we will call resource load item. For this one, you just need to provide a manager and also the array of items that you need to load. And what this function does is to, first of all, count the number of items in these resources, and then assign the manager if needed. Then we will load all these entry one by one, and we use the manage load function, put in the manager, the ID, the path, and maybe some extra argument. So you can see that this extra argument actually will work for the font because we set it here explicitly. And for this two, it doesn't matter because in the loading function, we actually don't use the extra argument. So it is fine to do this uniform loading using this function here. So that would be the actually the setup for loading all these resources. And let's see how we actually load them up in this expose function, resource load. Now, to load that, we just need to have, first of all, load texture using the dedicated resource load texture function. And then for all other resources, we basically do the same thing. We get the manager and then put in the items that we need to load, and then we use these resource load items to do it. And that is the same for fonts, music, and sounds. So that is the function that we are going to use to load all the resources. Now, we're going to think, where should I put this resource load function? Well, there are two places that we can put. First of all, we can, because we are going to initialize our app scene anyway, we can put the resource load function here, or we can put it in the main function here as well. I usually like to put it into our main function here because this resource load is actually part of the initialization of the engine. So I will usually like to put it here. We initialize the engine first and then load the resource and see if we can load it successfully. If not, then we are not going to continue this process. Otherwise we will go into our normal event loop like this. So that's how we load this resource. Now, next, how can we use this resource though? The idea to use them is not too hard because we have a set of functions to manage our resources already. So I'm going to show you how to do it in app.c here. In this function, you can see that we have our function to load the, give me a second, we have a function to load our texture here. Since we have our manager to manage all the textures, we don't need to load our texture on our own. So instead of doing this, we're going to do the following. I'm going to delete this one. And before I do so, let me include resources. This one will give us the texture ID. And then we're going to, first of all, first of all, get the manager. The manager we're going to use is the texture manager. And then we're going to set this scene texture to be, we're going to get from here. And then we would like to get the apple texture. And that's it. That's how we get the apple texture. In this case, since the manager will take care of the memory claimed by the texture, we don't have to, and actually we should not clean the texture at the end. But we can do the following. We can set it to null so that we won't accidentally use it after we free the screen. And that's pretty much it. And this here will remain the same. And if we run it, we will still get the apple on the screen here. And we can do this do a experiment. For example, we can train it to a snake body. Let me use body. What body is it? There was a head, I believe. Yep, heads up. See if I can draw the snake head here. So you can see that instead of the apple now, I get the snake head pointing up. You can see how easy it is to handle the texture if I use this set of functions from the manager. And I think it is quite neat to do it in this way. However, it might be not sufficient if you have a very complicated resources to load. And we might talk more about this one later when we try to make a loading scene. But for now, let's stop here and we will come back to more about this series later.